So this is Algebra 2, section 2.3, and I'm just going to explain really the majority of the types of questions you'll see for this section. So these are all about transformations, which you were introduced to at the beginning of the chapter. So this first question, I'll zoom in for you. It says, the function g of x is a transformation of the quadratic parent function f of x equals x squared. What function is g of x? So you can see on the graph, the f of x, the parent function, is right here in blue. So this is the parent function, y equals x squared. So it's a parabola, which we call a quadratic function. Then g of x is actually what we're looking for. So this equation right here, I'm just going to make some notes. It's flipped upside down. So we say that's reflected over the x-axis. So it's reflected over the x-axis. I'm going to write all these down for you. And it's also, if you can tell, it's a little wider than the original graph. So like on the original graph, and I'm going to do a black pen here, we have 5 critical points that I have you kind of memorize or recognize. So 0, 0, 1, 1, 2, 4, and then negative 1, 1, negative 2, 4, okay? So if you can kind of trace on the reflected graph, so on the g of x, if you can kind of trace where your points are, there's 0, 0. The next point on the grid looks like it's here. So 2, 2 instead of 1, 1. And then the next one we cannot even see. So it's stretched, or sorry, it's not stretched, it's actually compressed. So we're going to say there's a compression. It's flatter than the original graph, or technically wider is what it looks like, okay? So the graph looks wider, and that represents a compression, okay? So when I have a reflection means that I have a negative in front of my graph. So automatically, I know it's not A, I know it's not D, and then I have to decide, is a compression a fraction, or would it be a number larger than 1, okay? So what we do is we say, and this is just kind of like a little lesson here, if we have a number in front of our x squared, we say if this number is greater than 1, so like ignore the negative, if the number is like 2, 3, 4, 2.5, any number bigger than 1, we call that a stretch of our graph, and it actually is going to get skinnier. So I'm going to say stretch, and the graph would visibly look skinnier. If A is a fraction or a decimal smaller than 1, so we say it's a number between 0 and 1, it's a compression, which physically, when you look at it, the graph gets wider, okay? So for us, it should be a fraction or a decimal. So we can tell, based on all of our options, it's a negative, which reflects it flips it over the x-axis, upside down, and then it also is a compression because the parabola is wider than the original one, okay? Okay, for number 2, we're going to do something similar. I want you to note what happens from the parent function. So this time the parent function is the square root function. So I'm going to say y equals the square root of x, and it tells you that in your original problem. And then I want to know what happens from the parent function to the black graph, the h of x function, okay? So I'm going to, in red, kind of identify what my transformations are. So if you look at, again, your original points, it starts at 0, 0. There's a point at 1, 1. Your next point is at 4, 2, okay? And so those points come from like the beginning of this chapter when you talk about the parent functions. So on my new graph, it shifted left 4, so I'm going to make a note of that. It shifted left 4 units, and then the points are the same, so it's still from there you go right 1 up 1, or you go right 4 up 2. So those points, technically all 3 of those points are shifted to the left 4. So this is our only transformation, okay? Okay, so then we have to go back to like, how is that represented in a function? So for a square root function, if you add or subtract a number inside, and so let's not use a because we already used a. If you add or subtract a number inside with the square root, or sometimes it would be like maybe you're adding or subtracting a number inside parentheses if you're squaring something. So anytime it's inside the function, and you're adding or subtracting a number, it moves it left or right. So if we add a number C, it actually moves it to the left. If we subtract a number C, it's going to move it to the right. Okay? So left or right. So if we move left 4, it's going to be the square root of x. I'm going to add 4 on the inside of my square root, which is why you can see they select the correct answer is selected there. Okay, this one. What is the effect on the graph of f of x equals 1 over x, that's the reciprocal function, when it is transformed to this new function? So it's saying, basically, here's our parent function. If I just subtract 7 from the parent function, what's going on? What happens to our graph, okay? So again, what we learn about our transformations is that if I take my parent function, so in this case, 1 over x, and I add or subtract a number, we'll call it d this time. So if I add or subtract a number just to the fraction, or maybe I have x squared and I add or subtract a number to my x squared, or if I have square root of x and I add or subtract a number not inside the square root, okay? So when you have your parent function and you just add or subtract a number not directly with the x, but like with the function off to the side, that number moves it up or down. So if you add a number d, it's going to move up that many units. If you subtract a number d, it's going to move it down that many units. So in our problem, when I look at this, I am subtracting 7. That tells me it's shifted down 7 units. So I want to pick the option that says the graph is shifted down 7 units, okay? All right, so this time we have a new parent function. So you can see on your graph, f of x is the cube root of x. So we have our parent function this time is the cube root of x. And they're asking what is the new graph of g of x. So what I want to do again, the cube root has some different critical points. We have 0, 0, 1, 1, negative 1, negative 1. And then my next point is like all the way at 8. So it's off the graph. It'd be like, if I extended this a little bit, it'd be 8, 2. And negative 8, negative 2. Okay, so you can't see that, and I'm going to get rid of those lines. So I want to know, where does, kind of like this flexion point, how does that shift my graph? And then from there, it's right 1, up 1, and left 1, down 1. Okay. So the points don't change, there's no stretch or shrink, it just shifts. So if you can look, we want to see like it shifts from this point at 0, 0 to this point at 2, 1. So if I talk about left, right, up, down, I'm going right 2 and then up 1. So right 2, up 1. And I'm going to write that out, right 2, up 1. That kind of shifts the center of my graph. Okay, so we have our parent function again. I know that in order to shift a graph left or right for my parent function, I would add or subtract a number inside. So right 2 is going to be inside. And then to shift it up or down, I would add or subtract a number on the outside of the square root. Okay? So I want to kind of reflect that here. So this is going to be the the cube root of right 2. So think about what I told you before. When we shift left or right, I'm even going to go back up here. If you shift to the left or to the right, it's the opposite of what we might think. So like adding a number shifts it to the left, subtracting a number shifts it to the right. So if we want to say right 2, we are going to subtract a number 2 under the radical. And then up 1 is just regular. So add a number 1 on the outside. Okay? So subtracting 2 inside, adding 1 on the outside. We just want to match our equation. Okay? This first option, so if we just kind of look at this first option, that would be shifting right 1, because we're adding 1 on the inside of the radical, and up 2, we're adding 2 on the outside. So subtracting 1 on the inside moves it right. Adding 2 on the outside moves it up, okay? And we could kind of go through and describe all of those. Okay, so I'm going to erase that because I don't want you to think that that's the correct option. All right, next one. Number 6. Okay, this one is a graph. So an art store sells packages of 2 different sized square picture frames. The side length of the larger frame, S of X, is modeled by this function. So it says S of X, I'm going to write this, equals 3 square root of X minus 1, where X is the area of the smaller frame in square inches. Which graph shows S of X? That's how we say that. Okay, so I want to describe what this means. This 3 on the outside, we're multiplying it by the whole function, which is a square root, which you see in like the blue dashed graphs. This is a stretch by 3, okay? So when you multiply by a number bigger than 1, it's a stretch. We kind of said that makes our graph skinnier. That's for a parabola. So like for a stretch by 3, what we can think of is it's going to get taller. Like if you stretch something, it gets taller and skinnier technically, okay? And then this right here, the minus 1 on the inside, remember that moves it left or right. And if it's a subtraction, it actually goes to the right. So right 1. Okay, so I want you to think our original graph starts at 0, 0 for all of these blue graphs. And I kind of think of this part first. I want it to shift to the right 1. So like this one, D, is shifted to the right 1. C is shifted to the right 1. B is not shifted to the right 1, it's shifted left 1. A is not shifted right 1, it's shifted left 1. Okay, so we already have kind of canceled out a couple of our options. So now we just want to figure out, okay, which one is a stretch by 3? It should be getting taller. This is a compression by 1/3 or a factor of 3. This is a stretch, okay, because it's getting taller. So C is our answer for this one, okay? I believe this is kind of similar. So this shows the absolute value of X, which is a V-shaped graph. Again, you kind of talk about that in the beginning of this unit. So we have 1/2 times the absolute value of X, and we want to match it to the correct graph. So really we just have one transformation here. This is a compression, vertical compression, by 1/2, or technically a factor of 2. So to us, our graph is going to get flatter. So it gets, we said wider with a parabola, or you can think of it as flatter. However is easier for you to think of it. So horizontally it technically gets wider, but vertically it's flatter, okay? So the only one of our graphs, like if we look at A, this is shifted to the left 2 units. That's not what we're asking for. This one is a stretch. This graph is getting skinnier. So you can see this new parabola, the black one, is skinnier than the original parent function, okay? So that's not it. C is shifted up 2, so it's the exact same shape. The blue graph and the black graph are the same shape, but it's just shifted up 2, which we're not looking for. This one, you can tell, is actually wider. So this graph right here is flatter. It's like a shrunken down, compressed version of the original one. So it's kind of flatter and also wider is how we could describe it, okay? And that's a compression. All right, a couple more here. So what is the effect on the graph of f of x equals x squared when it is transformed? Okay, so we want to look at that equation right there. So I'm going to rewrite this. H of x equals 1/6 x squared minus 9. And what I'm going to do is I'm going to like put a little box around this parent function. And then we're going to say, okay, everything outside of the parent function, outside of the x squared, all the other numbers are transformations, okay? So remember, I just want you to like ignore all the options there. When I multiply x squared, or when I multiply my function, my original function right here is x squared, by a number in front, if it's a fraction or decimal smaller than 1, we say this is a compression, okay? And technically, I've just been saying compression. This is really a vertical compression. So vertical compression by a factor of 6 or 1/6. So however you want to think of it, it's going to say by 6 in your options. And then when we're adding or subtracting a number, there's no parentheses, there's no square root, there's no fraction, nothing like that. So if you're just adding or subtracting a number, it shifts it up or down. This one, because we're subtracting, it's going to be down 9. Okay, so I see 2 that say 9 units down. So here's 9 units down, here's 9 units down. So it can't be A, it can't be B. And then vertically compressed by a factor of 6. It has to be D right there, okay? This says horizontally compressed. It's not a horizontal compression, it's a vertical. So we haven't talked about horizontal compression up to this point, I don't think, okay? All right, another graph one. We want to find the correct equation here. So what we're going to do, this is obviously a stretch of our graph. And there's only, like if you look at your answer options, there's only one equation that's a stretch of our graph. The reason I know it's a stretch is, again, if I look at my original points, like 0, 0, 1, 1, these points on the grid, I can tell they're changed. So 0, 0 is the same, but this one is stretched all the way up to 3 and all the way down to a -3. So it goes from +1 and -1 to +3 and -3. So it's stretched, it's getting much taller, okay? It grows much faster. So I want to make a note here. It's stretched by a factor of 3. So when we have a stretch by 3, I know I'm going to take that original parent function, the cube root of x, and I'm going to multiply it by 3. So 3 times the cube root of x, okay? It doesn't shift left or right, up or down. It's not flipped, reflected, anything like that. It's just a stretch. All right, last one here. Okay, this one we have the parent function of the reciprocal function, f of x equals 1 over x. It says it shifted 5 units up and then 8 units to the left, okay? So 5 units up. So I want to take just this part. So I'm going to take 1 over x. 5 units up. I know that just takes that original, that looks weird, sorry. 1 over x. It takes that original fraction and we just add 5 to the fraction. So like off to the side, we're just going to say add 5. So again, when you go up or down, you just add or subtract a number off to the side. Now, 8 units to the left, that second part is right here with the x. So I add or subtract a number with the x in the denominator there. So 1 over, we have this plus 5 here. We have x. Now I have to just decide, like, am I adding 8 or subtracting 8 if I go to the left? So right here, I'm going to say left 8. I want to put that with the x. Okay, when I move left or right, it's the opposite of what I think. So left 8 is going to be plus 8, okay? So I add a number 8 with the x. Technically, this is kind of like isolated in parentheses. The parentheses aren't shown there, but they are there. They're technically there. And then I'm adding a number 5 off to the side of the fraction, okay? So left 8 would be adding a number 8 in the denominator. Up 5 is adding a number 5 just off to the side. Okay, and those are your transformations.